Dear students, I welcome you all to this of the fundamental course of civil engineering, fluid mechanics. Fluid mechanics is the foundation course for civil engineering, mechanical engineering, electrical engineering, chemical engineering, and mathematics. Fluid mechanics deals with the behavior of fluids when the fluids are at rest and when the fluids are in motion. You know, matter exists in three states: solid state, liquid state, and gaseous state. Liquids and gases are called fluids. Today, we will discuss the first lecture in the fluid mechanics course. In this lecture, we focus on what is fluid mechanics, what do you mean by a fluid, in what way a fluid is different from solid, and what are the various properties of fluid we generally require in this course of fluid mechanics. Let us go to the whiteboard. I will share the screen. So, what is a fluid? This is what we are studying. Fluid, a liquid, or gas. Okay. Then, what is the? Is it has any shape? No, it has no shape on its own. But it conforms to the shape of a vessel in which it is kept. However, the most important thing is the third definition. If you now understand first, if you now take a solid, now this I have fixed. Now what I have done, here I applied the force. This force is called shear force. This is what is solid, right? I applied shear force, which is also called as tangential force. So when I apply shear on this, suppose this, I will write it as AABB. You understand? This is AA and BB. So now what I observed is when I apply shear stress to it, this body deforms like this. This body now deforms like this. That means instead of AA, it becomes AA dash and BB has changed to BB dash. That means deformation has occurred, a straight thing to an inclined thing. This is the angle of deformation alpha. It deforms up to this and it stopped. This alpha is constant in case of solid. That's it. Even if you are applying, then this deformation is constant. This alpha is constant. It doesn't change. Even if you're applying it with the time, this angle is constant. Whereas now, if I take a fluid, for example, so this is a fluid which I kept here. I kept the fluid between these two, right? Bottom is fixed. Now I apply the shear force here. Original thing is this AA PB. The moment I have applied shear stress, the deformation has started. This is the deformation. As the time progresses, this deformation is also continuous with the time. The deformation is continuous with the time. The deformation is not constant. The deformation here, if you see, the deformation is continuous. Here, this alpha continuously changing. The deformation is continuous. As long as you are applying the force, as long as you are applying the shear force, here in liquid, the deformation is continuous. What it means, here, this alpha is not constant actually. Here, alpha is constant in solid. And here, as long as you're applying the shear force, the deformation is continuous. That is what we understand. So, how I write that sentence, if I take it, how to write that the same, I express it in terms of a sentence. That means fluid means actually it undergoes continuous deformation under the action of shear force. However small the shear force is, however the small shear force is, as long as you're applying the shear force, deformation is continuous. Continuous deformation, what it mean actually? It means flow. That means fluid is a substance capable of flowing. So kindly remember, this is the important word that you should write as a definition of a fluid. Never forget this part, right? This is the fluid. And as already I mentioned, fluids are actually, again, we know fluids means the liquids, gases, both we call it as fluids actually. If now again, if you want to really see, already I showed you the difference between these two also. Again, one important thing at the beginning itself, you should know that is what is the difference between ideal fluid and real fluids. This is a very important thing that every one of you should know. Kindly remember, ideal means, you know what do you mean by ideal? Something which we feel that it is not exist. It doesn't exist actually. It does not exist. Please remember. It is only a concept developed by mathematicians to analyze fluid flow. But what it is, okay, but how to define it? How to define a fluid whose viscosity and surface tension is zero and is incompressible is called ideal fluid. That means viscosity zero, surface tension zero, not compressible. Then we call a fluid as ideal. It does not exist. All the fluids in nature are real fluids. However, for study purpose, we consider water as ideal fluid as its viscosity is small. This is also only for study purpose, not really actually. So then basically, what is the why we analyze like that normally? Suppose if I assume the fluid is ideal fluid, what is the advantage for me? So when the fluid is ideal, there is no resistance. When the fluid is ideal, when the fluid is ideal fluid means no viscosity. No viscosity means no viscosity. When no viscosity means no resistance. This is the only thing that you should. So all fluids exist in nature. All fluids exist in nature are real fluids, right? That means they possess, they have viscosity, surface tension. So this is what the next one. But before, if you want to study fluid mechanics, first we should know what are the units. Why units actually? Units means actually the quantities measurement. Quantities measurement. Any physical quantity you have to measure. So that's why you need units. Then next, unless you have the units, that means then naturally it is not possible for you to analyze or derive anything. So that's why units are so important for you. But fundamentally, the main reason is if you want to conduct any mathematical operation, then you need it actually. Or if and you want, for example, to derive any conclusion, we need to explain the units. So that's why, and at this same time, these systems should be units should be such that actually it is internationally accepted. Otherwise, naturally, it cannot be different. Internationally accepted units that we need to follow. What is this internationally accepted units? Now, the international system of units, international system of units. What is that international system of units? So remember, it is SI system. So it is called as System International. So according to this System International, any physical quantity you have two ways. The quantities are defined as fundamental quantities and derived quantities. So, what do you mean by the fundamental quantities? The fundamental quantities. Fundamental quantities. Please remember number one, mass. Its unit is kilogram, small kg, right? Number two, basically, length. It is meter. Number three, time. Its unit is second. Number four, basic electric current. Its unit is ampere. Then number five, thermodynamic temperature. It is Kelvin. Number six, luminous intensity. Its unit is candela. So these are the six fundamental quantities as far as the system international SI system is concerned. But what we are going to take is 1, 2, and 3 are important for us in this particular course. So mass is in kg, length is in meter, time is in seconds. Then what do you understand by the derived quantities? Any other physical quantity is derived from this fundamental quantity. We require first thing in the derived quantities is the force. And all force, for example, then if you want, for example, the weight, if you want, for example, the what you call it as energy, if you want a work, all these are derived quantities. How we derived the force? Force is derived from Newton's second law. Newton's second law of motion, right? And Newton's second law of motion, F is equal to mass into acceleration, that which we know already. So here, if this is the case, the force is equal to, right? Mass is kg into acceleration meters per second square. And this unit is called as basically Newton. This is the system international unit. So Newton, yeah, capital N, because the capitals are used in units when they are expressed in terms of scientists' names. For example, the joule, J, and then similarly watts, it is named after what? W, capital W. So when you are now, when we are giving it in terms of a scientist, we are writing it as capital. So what is the force unit actually? What is the force unit in fluid mechanics? Kindly remember, it is Newton, capital N. So with this, we will go into naturally the fluid properties. So we take into the fluid properties. Before I take you into fluid properties, I will just name the fluid properties in today's class and I will stop it there. What are the various fluid properties which we study? What are the fluid properties we study? Number one is mass density. This is very, very important. Number two, then the specific weight. Then number three, specific volume. Number four, specific gravity. So this is one part, right? Then what is number five? Viscosity. As this is very, very important, we allocate separately this category. Then sixth is surface tension. Seven is capillarity. These two we look at as separately. Eight is basically we can take it as bulk modulus. 9 is compressibility. 10 is vapor pressure. So now if you see these four one category, this is separate category, these two are one category, and these three are one category. So finally, how many categories? First category is mass density, specific weight, specific volume, specific gravity. Second category is viscosity. Third category is bulk modulus, compressibility, vapor pressure. Fourth category is surface tension, capillarity. That completes the total fluid properties. So that you tell me in the class actually. With this, I will stop this lecture. Thank you. Thank you so much. One. Have a great day.
Like, share, and subscribe. Hit the bell icon for more updates.